again, and I'm glad to see all of you students, and hope we can have a fruitful conversation today. I'm going to be talking to you using PowerPoint slides, since I'm an engineer, and engineers can barely say a word without PowerPoint slides. I'm also in love with information, so I'm going to be sending a lot of information your way. However, I have no objection to you. In fact, I encourage you to interrupt and ask questions if you have questions, because that way we can have a conversation about this. So I'm going to share my screen here. Let me see if I can get, yeah, here we go. Yes, can you see my screen now? Okay, good, good. So my topic today is decision support technology and benefits and risks to disaster management. So I'm going to hit, and I'll talk about this in more detail. I'm going to talk about this at 3 levels. First of all, a bit about the technology itself, because technology is, the available technologies is really a very rich field. Technologies are more accessible than ever, and there are many options there. So as an emergency manager here in your simulated task force, you may have the opportunity to engage many types of technologies, some easier and some harder to bring in. However, in addition to becoming aware of the technology, the potential of the technology to help you, there are challenges in incorporating technology in any organization. And so I'll be talking about some of the personal and organizational challenges associated with bringing in technology. And then the third part, I'll be talking about a broader view of how, once technology is embraced, and even after you've gotten it working, it can create risks of its own. So let me start here. See if, okay. So let me say a little bit more about who I am. My name again is Tom Robertson. I have 2 main hats these days. One is I'm the principal at a consulting business called Thinking Teams. And what we do is harmonize human and machine intelligence. And so this is bringing together computers and people, and in particular, some of the exciting new advances in artificial intelligence. I've also, for some 8 years now, been director for North America for the International Emergency Management Society. And this is a group that works worldwide to spread knowledge and best practices in emergency management. And as you know, emergencies, very often the most severe emergencies, are rare, although many of them are becoming more common these days. So there's a huge advantage to be able to pool the experience across the world. And so we work in that domain. So my background is in engineering. I started out as a research engineer and then became a manager. Later, I became a consultant to organizations, management and organization consultants. And then in the last years of my career, I've applied that to emergency management. So I'll be trying to impart some of my experience in the technical domain, both as a researcher and as an implementer, as well as in the management aspects of this. How do you engage the people that need to be engaged in order to successfully implement technology? So let me trying to figure out the best way to organize my screen here, because I found if I'm just, I'd rather stare at you than my slides, because I want this to be a conversation. All right, so let's go. As I mentioned, the theme for this session is that there are a wide range of decision support technologies that can potentially benefit your disaster management situation. As you try to employ those technologies, you're going to encounter some organizational as well as technical challenges in doing that. And even after you get the technology working, there are going to be new risks that emerge specifically because you've started using this technology. All right, the first part, I'm going to talk about some example technologies just to give you an idea of the range that's possible. Some of these technologies are really quite accessible, being accessible on smartphones, for example, and through open source software. This initial example is a project that was actually a high school student project to support wildfire prediction. And the idea was to employ technologies out in the field that would be able to be polled and send back information about the relative likelihood of wildfires in a particular area. They did this through a station, you can see it here in the picture, that employed a number of weather data sensors like humidity, temperature, gas, carbon monoxide, dioxide, and wind with images. And the images were classified according to the nature of the vegetation. And that together with the weather data indicates a probability of a wildfire happening. And so in order to map the patterns in the input data here, weather and images, to the probability of wildfires, they used machine learning. And this is a theme that will come up because it's a very popular technology these days. Machine learning is a way to create a system that will predict things like wildfires from patterns of input data. And the way the system works is you train it with lots of data, and through a training procedure, the parameters of the models, parameters of these systems are adjusted until they give reliable results. This has gotten to be a fairly mature and accessible technology, and people like these high school students, you don't need to be a specialist in developing these complex machine learning systems. You can get them pretty much off the shelf and begin to use them, which is what they did here. Another example of using machine learning is something that was a joint project between Google and the Central Water Commission of India. This is one to predict floods in India, which is extremely important. India has a lot of floods, and 20% of global flood fatalities occur in India. And so here it's based on historical events for a particular area, river level readings, and terrain data. And by looking at all of that across years and through different regions, a machine learning system was trained to be able to give alerts and to be able to predict where the situation of flooding in particular areas. And as you can imagine, being able to access this sort of information on a smartphone can be very useful for emergency responders as well as the public. Another smartphone type application that deals with machine learning and looks at patterns is using information collected in the field to fight armyworm in Africa. You may never have heard of armyworm, but the fall armyworm threatens the food security of over 300 million people in Africa. So the idea of this project is that workers in the field can take a picture of the crop with their cell phone, upload the data, And through this information, the central computer facility, which has been trained on images of crops that may have been affected with armyworm, it calculates the level of infestation. And based on that, it provides knowledge from a knowledge base to the farmers in order to advise them on how best to deal with this problem. One advantage of this kind of centralized system is that you can take the information and add it to what was previously known about the relationship between patterns in crop pictures and the infestation of armyworms, and it can get smarter and smarter. It can get better and better at making the predictions. Of course, there are more expensive technologies that support decision support. Drones, for example, is one example. This is a system called Hoverfly that can be set up from a mobile base to surveil day and night areas where a disaster may be impending or in place or in recovery. And so this can create surveillance footage. It has real-time capabilities to be able to provide real-time video as well as analysis based on the pictures. As I mentioned, because machine learning is fairly mature these days, you can set up any kind of system that's streaming video to fairly reliably sort through the images and give you some information. Look out for things that you need to be alert to. The previous examples of technology were kind of, had sort of a local aspect, a thing that you could access through smartphones. And they also had a central aspect where information was collected, machine learning training occurred, and that sort of thing. Some projects are broader scoped, and a number of projects I've been involved with take advantage of the Internet of Things or smart cities. And the idea here is, as you probably know, many cities across the world have been taking advantage of the availability of powerful smart computers, wireless communications that pervade urban spaces, and cloud computing to bring all this together so that information can be brought together and disseminated in ways never possible before. So here's an example of a Rio de Janeiro system that was set up that incorporates a central operations center that takes in information from rain gauges, radar sensors, GPS, various images, as well as social networks, and coordinates the activities of over 50 agencies. So one of the problems they were trying to solve here is that Rio would be subject to catastrophic flooding and landslides from time to time. And so they needed to have a more coordinated, better response in terms of where do you need to send the traffic, or what good operations routes are, evacuation routes are there, and so forth. And so from this operations center, ingesting this data, by pulling together this information, it provides guidance for the folks in the operations center to recommend actions in response to the emergencies. They can put out social media posts and use it to disseminate authoritative information during the outbreak. They can communicate with news outlets so that people can get over their news sources appropriate information that will be helpful in coordinating the response. They can even automate sirens, manage traffic flow through signals, and also be able to broadcast traffic maps that shows wait times. So this is an example of obviously in engaging and planning for and implementing a system like this is a much broader undertaking than taking advantage of off-the-shelf components to monitor for wildfires, but it's can be very effective, especially when you're talking about a large city operations with 50 agencies cooperating. So it may be, as individual emergency managers in a position like the simulated emergency that you're working now, that there will be an existing system like this that you will have the opportunity to take advantage of or tie into. For some of these other, less complex system, you may have the opportunity to actually set something up, especially in anticipation or in response to your emergency. And finally, I'm sure many of you are familiar with blockchain, which is the technology behind Bitcoin. And it's an information technology that allows for secure and sort of indisputable, incorruptible transactions to take place. One thing you may not realize is this has actually been applied and investigated for use in emergency management systems. And basically, the advantage that this sort of thing brings is that, particularly for very large scale responses, you have a lot of people interacting. So there may be not only coordinating operations, but there may be government engagement, government funding, sources of finance. There may be suppliers of goods, and in international responses. In fact, one of the problems is information flow. TIEMS, my organization, is currently working on an initiative in the current Ukraine crisis. What they found is Ukraine needs aid. They need hospital supplies. Their emergency systems are stressed, and there are no shortage of donors throughout the world willing to help Ukraine. But the problem is that there may be one hospital that needs 2 X-ray machines, and they may receive 10, and another hospital that needs 5, and they don't get any. So coordination of needs to suppliers of needs often is a challenge. So blockchain can be used to set up verifiable, unmistakable, no error kind of connections between needs, supplies, and finances. And so the hope is that eventually, by applying this, there will be the less need for many people in the middle to try to coordinate, to try to approve, and things will go more effectively and more quickly, and there will be less margin for error. So that's an example of obviously, to set up this sort of thing is a fairly large endeavor, but again, it may be that there's a backbone system that you can take advantage of in dealing with your particular emergency. So let's now get to beyond the technology. All these, there are many technologies available, and the ones I mentioned are actually several years old. And every year there's more available. And one of the fascinating and important things that goes on particularly in the computer science community, is that there's an amazing amount of work that's open source, and that is people who are volunteers willing to apply their expertise in developing software and making it available for worthy purposes. And it's very easy for people to see how emergency management you see the worthiness of emergency management as a beneficiary of their work. So there's all kinds of software available, and In using this, it will always be in the context of an existing organization. You will be part of an organization, a municipal organization, emergency management organization that will be bringing in that technology. And it's long been recognized that there are multiple dimensions and challenges to this process of bringing technology in. So I'm going to talk about some of the root causes of that and some tools that are out there that can help an organization deal with this better. And what I want to emphasize here is that, of course, engineering systems and so forth is fairly structured and hopefully precise as it goes. Some of these additional challenges associated with organization and people are certainly less subject to laws like the laws of physics and engineering. However, there are a surprising number of techniques that can be brought in to an organization that will make all this go better. So I'm going to talk about some of those options as well. So what makes where do the organization challenges come in applying decision support technology to emergency management, to your particular organization? Well, the primary reason is because there are multiple players and stakeholders, and they all come at things from a different point of view. For example, they're the technology users. So within an emergency management organization, there are responders, of course, people who may be relying on cell phones and communications during their response. The public often is part of the user of the technology, as decision support technologies can use social media, for example, to get out information associated with this. Within emergency management, there are IT folks often, and very often they're the ones who are on the sort of the interface between the organizational use and the ingestion of technology that comes in from an outside source, from a vendor or from open source that supposedly works and so forth. And within emergency management and municipal and organizations, there are supervisors and managers. The line's blurry there, but what I want to differentiate there are those who are not directly operating the equipment, but responsible for the harmonious coordination of the overall activities. And then there are managers who are responsible for budget and schedule and bringing things in and creating the environment and the culture that allows for the effective use of the technology. So beyond the technology users, there are the developers themselves, and sometimes, particularly now that there's free open source availability, if your organization has sufficiently expert IT people, an emergency management organization itself may actually be the developer, so that you'll have your IT people developing technology for the users. In other cases, you'll be buying technology from the outside, and dealing with vendors has its own challenges, as I'm sure you all know in your own lives. Often vendors can come across very confident in the applicability and effectiveness of a technology, and sometimes it turns out to be overly optimistic when you actually try to do it. So getting beyond the hype is an important thing. And then finally, there are what I'm calling technology enablers. And these are people that are trying to help the organization better prepare in the broader sense. So executives, they have the vision to and the ability to take means of allocation of larger budget, capital investments, that sort of thing to sort of put things going, get things going. And consultants like me, for example, are often part of the trying to figure out how best to match those other two groups, the people, the technology and the people that develop them with the technology users to come up with a effective and useful result. So one of the things that makes this different, back, let's see, if the fact that these multiple users all have different points of view is, and this is something I wanted to talk to you about that I use in some of the training and coaching I've done in engineers who are trying to transition into management. And I think that this challenge is something that is a good illustration of why it can be challenging to work with people who are all trying to do the same thing, but they're looking at it differently. So what this chart does is it talks about 5 different dimensions or aspects of work: identity, independence, values, influence, and learning. And how those things are looked at from the mindset of an engineer compared to how a manager needs to look at that. So, for example, as an engineer, and I can kind of identify this because I've been both. I'm very proud of my expertise, the tools I know how to use, and I really evaluate my worth by the quality of the products I produce. On the other hand, as a manager, the managers are certainly interested in quality products, but their concern is really for the organization. And if they're a good manager, they need to give up on personal, too much of an attachment on their own personal gain and look at the organization as a whole. And of course, they get things done through relationships, not through technology and hands-on expertise. Another aspect is independence. Engineers highly value independence. We want to believe we're independent thinkers, that our idea is the best one, and that our personal contribution is higher than anyone else's. We take pride in that. Managers, on the other hand, are all about making sure that there's collaboration and that those who work together are not separated by competing independent goals, and they're concerned with the group of the success. And so a trick for any manager is to bring that about and allow personal contributions to be, people to be proud of their own personal contributions, and at the same time the group succeeds. Another different aspect, and I think this plays across the organizations, different mindsets in an emergency management organization, is what is the thing you value most highly? And so for an engineer, elegance, perfection, uncompromising are values, and we go crazy wasting time interacting with other people. Just let me go back and do my work. Managers, on the other hand, have to adopt an entirely different mindset, recognizing that from the big picture, best can often be the enemy of good. And sometimes we need to compromise and come across with less than perfect or less than best technical solution in order for us to satisfy a higher level important goal. And, interacting with people, meetings, they're essential. They're how things get done. Another important thing, and I think this came up in something that Diego was saying recently, is how do you interact with people? How do you try to influence them? And one of the things I I observed in engineering organizations I've been associated with is that engineers are inclined to believe that it's the data that will decide. You know, it's kind of, in order for us to make any important decision, we just got to get the best data we can and, you know, evaluate the data. And we can both, any two people, any organization can agree on what the data is and when the data is good, when the data is bad, and we'll just look at that. And the problem is that often particularly in broader scale management decisions, there are decisions that need to be made where there is not insufficient data, or there's ambiguous data, or the best information we have is coming from a handful of experts who all have different backgrounds and different ways of looking at it. And so the decision needs to be made by a combination of collaboration, compromise, persistence, relationships, and so forth. And that can be a process that what I found is the engineering mindset can sometimes have a hard time wrapping their mind around, because they will see a management or an organizational decision that they disagree with, and they will automatically believe that, well, you know, I know what the data is, and I've done a thorough logical analysis of it, and if somebody else is coming to a different conclusion, they must have some ulterior motive I'm not concerned with. So that whole business of how you influence and how you interact is different. And so that's one of the important things to overcome in an organization. The other thing that's different in the work is how do you learn things? Where does information come from? And you know, you've often heard, I'm sure, the contrast between book learning and street smarts. And there is an area, particularly within engineering, where book learning is key. I mean, the information is solid, it's there, and you're really out to use that information to avoid making mistakes. You know, in fact, engineers, and I think it's true of many individual practitioners, learn to become allergic to mistakes. They are really looking for any source of error and trying to eliminate it, which is good. It serves them well. However, management deals with knowledge that is much more certain, in spite of the fact that there have probably been hundreds of thousands, if not millions of books written on management and leadership. There's always more, thousands coming out every year, because you can't put it all in books. It's tacit knowledge. It's things you learn from experience and practice. And there's no avoiding mistakes, because that's how most of us learn there. So to summarize, when all these groups of people at various levels of leadership, specialists in technology, people who need to use the technology, people who are allocating budgets and trying to take the long view, when they get together to try to implement new technology, it can be a challenge. And one of the key challenges is differences in mindset. So fortunately, through experience, there are three ways I'm going to talk to you about how these differences can be overcome. The first way deals with individual communications. And let me just give you an anecdote here. I was managing a group, an engineering group of researchers, and I had really interesting conversations with two of my senior people. One was a chief engineer. Chief engineer meant his job was to ensure and advance the technical quality of the work being done by the group. And he came into my office to report to me that he had been involved in a three-way conversation with the chief program manager of our group, him, and a third engineer. And he was just aghast at how unprofessional the chief program manager was in his interactions with this person. And I was very surprised to hear this, because I respected both of these guys, the chief engineer and the chief program manager. And I was, thinking about this meeting. The guy had come in, he was obviously upset, the chief engineer. But not too long after that, the chief program manager came in, and he had pretty much the same story. The bottom line was, in his experience of that interaction with the third engineer, he was just aghast at how unprofessional his fellow senior colleague, the chief engineer, was in dealing with this guy. So I thought, that's interesting. These two guys obviously have very different points of view of this interaction, and it's really not going to work to have two of my senior people disrespecting each other. So fortunately, I was able to get them to agree to come in to have a three-way conversation with me, and I facilitated them sort of talking about that interaction with the third engineer from their own point of view. And after, half hour, 45 minutes, it became clear that it was a difference in point of view. The chief engineer was being very critical of the engineer's results in order to motivate him to do better, because he knew he was on a great path, and it could succeed even further if the engineer kept going. And so the tactic of the chief engineer was to sort of paint the picture of how much better it could be. The other person in the room, the chief program manager, looked at that interaction and said, geez, you should be praising this engineer's work. He did good work. So instead, why are you pointing out the shortfalls and complaining to him that it's not up to snuff? The other point of view from the chief engineer was that the program manager, he could see, was upset about this interaction, was willing to let the engineer off the hook for what he viewed as performance that was less than it could be. And what the chief engineer didn't realize is that the program manager was also considering some considerations of schedule and budget, some other aspects of the program and the system that would permit the lesser solution from being effective, and so forth. So when all that came out in our meeting, it became clear that, okay, I get why you said that, and I get where you were coming from, and I think we both have a fuller picture. But very often in interactions with people who are, again, in a different department, from a different mindset, it's often easy not to have the luxury of meeting of the minds, and so there's a clash. So how can that be helped? Well, one of the best ways I've found is this thing called a mutual learning framework, and this attacks the problem at from the standpoint of individual person-to-person communication, or as a group. And basically, it says that when you're getting together to try to, say, jointly solve a problem, you've got the technology providers and the users in the same room, and you're trying to come up with, or multiple technology providers, your IT people and the vendor, and trying to come up with a solution. How do you have the most successful meeting? And Roger Schwartz, who was one of the guys working in organization development at Harvard for some years, developed this technique, and he pointed out that mindset shapes interaction. And when you think about it, and I'm guilty of this too, it's not, let's say we both prepared for a meeting to come in to figure out the solution for a use of decision support technology and emergency management. We both do our homework, proud of the conclusions we've come to, and we come to the meeting to champion them. And it's very often to have the mindset coming in saying, you know, I understand, you don't. You couldn't possibly understand as well as I do because I've really studied it. I'm right. Obviously, you're wrong. And, you know, I want to win. And the problem, that's a problematic thing. A better way that mutual learning talks about is that, you know, you recognize that, look, I have some information and inevitably my information is less. And other people have stuff I don't even know I don't know. So let's assume that each of us can contribute and let's deal with differences in a respectful way. And let's not assume that if somebody disagrees with me, it's from some sort of impure motive. And so, I don't know, maybe that sounds totally logical to you, but I found that it's surprisingly easy to slip into the more common mindset. And if one is able to, and this takes some practice, get into this other mindset, things can be moved along in a much richer and faster way. And we don't have time today to go into the various aspects of that, but Schwartz has done a good job of developing a framework based around some core values people agree to when they interact, ground rules, and something called the mutual learning cycle that allows people skilled in this to shape these meetings and overcome some of these differences and points of view. Here's another different kind of approach, and this is, you know, often in developing solutions for emergency management, applying technology, you need to engage the public because public acceptance is really important. This comes up, for example, in a program I was involved with the European Union in very relevant today, public health communication during pandemics. And during the previous pandemic, the H1N1 or swine flu pandemic, the European Commission thought it went into the pandemic very well prepared. They had planned for authoritative communication and plans for how the various departments in the government would interact with the public, engage with pharmaceutical companies for vaccines and all this. And when the pandemic hit, the results were very disappointing. And one of the things they discovered, because they were taken by surprise at that time by the power of social media, was that people were beyond just following authoritative advice. They had access to all kinds of information and were not following the expert advice that the original plans had assumed people would follow. So one of the ways they came up with to improve that was to engage the public earlier in the process of planning how to deal with this. And one of the most effective ways to do this is called deliberative polling. And this is a technique that's been developed. And basically what it does is it says, look, we want input from the public. We're going to go beyond just, say, sending out a survey. We are going to take the time and the resources to bring in the people involved. And by the way, this can also work for technology users and technology development. Get the stakeholders in, spend a day or two informing them on the issues and the options, and then let them deliberate on this. They will now perform an informed deliberation, and then ask them, well, what do you think? You know, should we go this way or that way? And the result will be a lot more useful. The stakeholders, in this case, the public that's been engaged, will feel much more invested in any solution, and you're much more likely to find out in advance things that, you know, if you just make assumptions and send something out and try to get your emergency responders to use it, you may find yourself disappointed. And the third method, so the first method was, broad speaking, how you interact individually and in groups. The second method was particularly if you have someone who's been needs to be engaged and is not normally engaged. This is more of a project management methodology you may have heard of already, called agile. It was first, I think, brought online for software development, and since then it's been used for all kinds of projects. And it's based on the fact that it was discovered early on in software development. Software development's been going on for 60 years or more. And as software projects get larger and larger, they became more and more disappointing. Time after time, specs were developed, systems, were enthusiastically funded, and results were over budget, over schedule, and sometimes a shocking number of very high-priced information systems never made it to operations, including some by the U.S. Postal Service, for example. And so for a long time, the profession said, well, what we really need to do, we just don't have our act together. We're writing code before we know what we really want. And so what we got to do is do more design up front, a lot more work before we even start writing software. And so a lot of tools came about to develop structured requirements and to guide the software development process. We call that the so-called waterfall method. Still, over budget, disappointing results, till finally some researchers put their finger on the problem, and that is that there are inherent uncertainties in any software development, in that you can never know up front exactly what you want and even what you need or what's possible. So they came up with this agile method that says, what we're going to do is we're going to start with a basic, broad vision and goals of what we're going to do. And we're going to assume there's a lot we don't know already. And we're going to, at every step, continue to engage all the stakeholders. So one of, a standard problem with past developments is there'd be some early interaction between, let's say, software developers and the users, and the software developers would say, we know what they need. And they give them what the software developers thought was just great in terms of the user interface and so forth, but the stakeholders the users couldn't use it. So this maintains engagement throughout. So when just plain usability will benefit, but even more importantly, when you find out through demonstration that, we thought we could do this, but we can't. Maybe the developers will discover that. Or maybe the users will say, well, we put that in the spec originally, but, we decided that isn't the best way to get it done. So it will come up, and jointly, all the stakeholders can understand, okay, we need to shift here. We don't have to adhere strictly to the plan. Let's move things, let's reallocate stakeholders. So this is all informed by demonstrations of preliminary prototypes early on, so that it's not a matter of trying to communicate through written specifications or emails, but you can actually tangibly see where you're going during the process and adapt as you need. And this actually encourages innovation and motivation. So not only are the users more likely to get what they need, but they'll inevitably get something better than was originally conceived, because opportunities will come up. And there's always this balance between, when you're developing something, the dimensions of good, fast, cheap, and it's, the standard phrase is you can only have 2 out of the 3 of those, and so you need to balance those. So I think I'm going to skip this now, but as you get into this, and any of you who become in the position of managing projects, you'll find that there's this balance between structure and flexibility that needs to be adapted to the size of the project. Finally, I just want to say a few words about, this is kind of stepping back even farther. As I mentioned, we talked about how there's a lot of opportunity to use advanced technologies for decision support. Bringing them into an organization in a successful way comes up against some organizational and people challenges. And now I'm getting, once you've gotten this technology in place, there are also some additional risks. And some of these are more able to be dealt with at the higher levels in the organization, but I'll talk about those. So let's talk about some of the advanced technologies such as machine learning. What are some of the new risks that happen? Well, technical failure can be one. You may be dependent on communications channels, and internet being up, even electricity that could fail during an emergency. Unintended consequences. I'll talk a little more about this. These are systems that are developed like machine learning systems that suddenly encounter a situation they haven't seen before, and the results are unpredictable. And as you know, with the advent of and reliance on the internet, there are opportunities for things like cyber terrorism. So let's talk about some things that can happen with advanced decision support technology, such as AI. Failure in novel situations. Machine learning relies on training from data, and the same would happen with a machine learning system that's attempting to predict an emergency or the result of emergency. If it encounters something it's just never seen, it can fail to give the right answer. In this case, this is an example from a self-driving car that had never been trained on a situation that it encountered. The situation was a pedestrian walking a bike across a road in the middle of the night, and it didn't recognize the pedestrian and hit them. Bias. Automatic facial recognition is often used to deal with security situations, and sometimes the training data can create biases. In this case, if you saw the full data on these two people, it's pretty clear that the Robert Cannon's dark skin was biased the result against the assessment of the risk here. As infrastructure, as we depend more on machines to make decisions, we can have problems such as the Colonial Pipeline situation that was held hostage by cyber terrorists, and the flow of gas throughout the eastern United States was interrupted. Lethality, this in the emergency management domain, this can identify additional terrorism opportunities, risks, and so forth by the other side applying technologies. You know, social media has a strong influence, as we know, that can result in spread of misinformation, which can definitely hamper emergency response, as you know. And whereas spread of misinformation is kind of peer-to-peer or public-to-public domain, there's also another kind of a problem that can result in control, such as use by central governments and so forth to control operations. And then this is sort of a broader thing. As automation infiltrates all operations, it can create growing unrest, which is always a backdrop problem to any emergency response. So how do you mitigate that? And let me just briefly say that, think about the disaster management community in terms of several levels. There are people who are in administration, those in charge of budgets, of running emergency management organizations, local, national governments. There are people in operations, who are the first responders, managing operation centers and so forth. There are people developing technology and doing research to support the technologies doing there. And the disaster management community embraces people across the spectrum here, and there are ranges of mitigating mechanisms that can be undertaken here. For example, policy, laws, and standards that will guide the use and prevent misuse. For example, where do you use facial recognition? Safety protocols and procedures. These are operational things that need to be wrapped around a technology to make sure when it decides to go south, it doesn't create problems. Testing and rehearsal in the operations community. Often this can create and inform safety protocols and procedures where you can simulate something going down and having to do it by hand during an emergency. Alerting and backup systems are things that engineers can build in. What happens when an element of technology stops and we need to continue operation? And then finally, there's ongoing research, for example, in artificial intelligence, to create designs that are inherently safer, that do a better job of monitoring their own operations and determining when they may be getting out of their depth. For example, self-driving cars that do not just try to determine where they're acting, but are monitoring their own actions and looking, specially trained to look for problems. So to summarize, there's a broad range of decision support technologies that might really help your disaster management situation. There are things that you could get almost for free if you can figure out how to use them. There are other things that would pay to make a broader term and long-term investment. To get these technologies working, you'll need to overcome organizational as well as technical challenges, because there's this bridge between people and technology and people with different points of view. And once you get the technologies running, they will bring new risks. And some of them we just talked about. So there you have it.